Okay, Math 710, surface area and volume. In order for you to be able to do good on this test, you're going to need to memorize these 3 formulas right here. Actually, it's 6, because for the rectangular prism, triangular prism, cylinder, you need to know total surface area and volume, total surface area and volume, total surface area and volume for each. So you might want to pause this and write these down and memorize. Okay, problem number 1. To draw the net of a cylinder, you would use a rectangle and 2 circular bases. So here's what a cylinder looks like. And if you were to open it up and lay it out flat, it would look like this. I think you drew one of these in one of the lessons. Maybe not. You drew the net of a cone and the net of a square pyramid. Okay, so I don't think you drew one of these. But this is what happens when you take the shapes of this 3D and you lay it out flat. It would look like this, which is 2 circles and 1 rectangle. So this answer is true. Okay, problem number 2. Pyramids and cones have an apex. Okay, so let's look at some shapes. Pyramids and cones. Here's a pyramid and here's a cone. What is an apex? An apex is that point you see at the top. So yes, cones and pyramids have an apex. Problem number 3. A triangular pyramid has a triangular base and 3 lateral faces. Okay, here's a picture of a triangular pyramid. The shaded part is the base, and as you can see, it is a triangle. And then if you were to count the faces, there's the one in front and then there's 2 in the back. So that makes 3 lateral faces. So this is also true. Problem number 4. If all the dimensions of a cube are multiplied by 5, the surface area of the cube will change by a factor of 25. True or false? What you learned in this unit was surface area changes by the square of the factor change of the dimensions. So what factor did we use to change the dimensions? We used 5. So you want to take that 5 and square it. What is 5 squared? Remember, 5 squared means 5 times 5, not 5 times 2. Okay? No, not this. This. Okay, 5 times 5 is 25. So this is true. The surface area will change by a factor of 25. Problem number 5. The length of a rectangular prism is 1.5 feet. Its width is 7 feet. Its height is 6.2 feet. So the volume of the prism is 130.2 square feet. Well, if you go back and you look at the formula for prism, here's the prism. And yes, it's a rectangular prism. And you look at the formula for volume of a rectangular prism, length times width times height. Then you would take the numbers 1.5, 7, and 6.2, multiply them together, and the answer is 65.1. So this is false. Problem number 6. The diameter of a cylinder is always twice the radius. Okay, so the base of a cylinder is always a circle. The diameter of a circle looks like this. Okay? The radius of a circle is always smaller than that. Okay? So the radius is always half of the diameter, or the diameter is always twice the radius. Okay? Remember that. Get that in your head. Diameter is always longer than radius. Radius is half of the diameter, or the diameter is twice the radius of a circle. Alright, problem number 7. Which of the following figures has 1 polygon shaped base. Alright, so remember, a polygon is not a circle. It has 3 or more sides. It's a shape with 3 or more sides. So let's look at these shapes here. Cone, cylinder, prism, pyramid. These we can X out because they don't have polygon bases. They have circular bases. Okay, these two have polygon bases. This is the base. This square right here is the base of this shape. A square is a polygon, yes. And then over here, this triangle is the base of this shape. Triangles are polygons. So, and then there's another base over here. I should have went like that, I guess. Prisms have 2 bases, okay. Alright, so when it says 1 polygon shaped base, that one's out because it has 2 polygons and this one only has 1. So it would have to be the pyramid. Problem number 8. Identify the following solid figure. Is it a hexagonal pyramid, pentagonal pyramid, hexagonal prism, or pentagonal prism? You need to know how many sides a hexagon has. A hexagon has 6 sides and a pentagon has 5 sides. Okay, let's take a look at these shapes. Okay, as you can see, the pyramids only have 1 base. The hexagonal pyramid has a hexagon base. The pentagonal pyramid has a pentagon base. And then on the prisms, they have 2 bases. A hexagon, 2 hexagon bases, and 2 pentagonal bases. Pentagon bases. So the shape, this only has 1 base. It's going to be a pyramid. And the base has 6, 1, 2, 3, 4, 5. This base only has 5 sides, so it's going to be the pentagonal, the pentagonal pyramid. 5 sides and only 1 base. Problem number 9. Which solid figure has the following net? Okay, here's a cube. This is what the net cube looks like. Here's a square pyramid. This is what the square pyramid net looks like. A rectangular pyramid. This is what the rectangular pyramid net looks like. And then a triangular prism. And this is what a net of a triangular prism looks like. So this matches up with a square pyramid net. Take the shape and lay it out flat. That's the net. And it's called a square pyramid because the base is a square. Problem number 10. Use the following net to find the surface area of the solid figure it represents. So since they gave us the areas of each face, all we have to do is add up each face and its areas, and we'll have the total surface area. So I wrote out all of the surface areas. As you can see, I did not use 6. 6 is not a face, and it's not an area, it's just a dimension. It's probably the length. So don't use the 6. Add all these up and you get 88 square yards. Okay, problem number 11. Use the following net to find the volume of the solid figure it represents. Okay. Alright, the formula to find the volume of a rectangular prism is length times width times height. Length and width are the length and width of the base. This is the base of this shape. So the length and the width are 8. We can just take this right here and put an 8. The height would be the next dimension right here, 6. The last problem I said this is the length, but apparently I was wrong. This is the height. So we're going to use 8 times 6 equals 48. Okay, and that's the answer for volume, 48. Okay, problem number 12. What is the surface area of a rectangular prism with the following dimensions? Okay, you're going to have to know this, have this memorized to find the formula when they give you dimensions like this, and not, well, up here they gave you all the areas of the faces. Here they did not give you all the areas of the faces. They only gave you the dimensions. So you're going to have to use a formula to find the surface area here. So first you need to just, where you see a letter, plug in a number. For L, length, you would plug in 8. For W, you would plug in 4. And for H, height, you would plug in 12. And it would look something like this. And then you're going to multiply each of these sections. And you would get this, 64, 192, and 96. And then the last step would be add these three numbers. And that comes out to 352. So the surface area is 352 cubic centimeters. Remember, we add this for cubic. Anytime you're looking for area, you're going to use this square sign. So not cubic, sorry, that's when you use a 3. This is 2, so 352 square centimeters. Alright, problem number 13. A rectangular prism has the following dimensions. If all the dimensions of the prism are doubled, what will be its new surface area? Okay, let's look back at problem number 4. Remember what happened here. If all the dimensions are not doubled but multiplied by 5, the surface area will change by a factor of 25. So we took that 5 and we squared it and we got 25. Over here it's not 5, it's 2, because doubled means 2. So to see what the surface area will change by, we're going to square this just like we did with the 5, and we're going to get a 4. That's what the new surface area will have to be multiplied by. So we're going to take 352 and we're going to multiply it by 4, which comes out to 1,408. So the new surface area will be 1,408 square centimeters. Put that little 2 there for square. So you could double all of these dimensions here and work it all out and find out the new surface area is 1,408. Or you can use the little trick they taught you in the unit to find the new surface area. This is a little bit shorter than doubling all of these dimensions and reworking the whole problem. Alright, problem number 14. What is the value of B? That's a capital B, meaning base. What is the value of the base of the following figure? Okay, so let's talk about this figure right here. Do you know what this figure is? If you look at this formula sheet here, it matches up with a triangular prism. Okay, the only difference between the rectangular prism and the triangular prism are the bases. This one is a square or a rectangle. This one is a triangle. That's why it has the name triangular prism. So what is the value of B for the following solid figure? We have to know that it is a triangle. This is B. This right here is the base of this figure. And there's 2 of them. They're exactly the same. In area, when you find the area, they'll be the same number. But the base of this figure is a triangle. And to find the area of a triangle, you have to go 1/2 times little b, which would just be this little line right here, 12, times height. And the height of the base is this, 5. So you have 1/2 times 12 times 5. Half of 12 is a 6. Times 5, just drop the 5 down. 6 times 5 is 30. So the area of this base, this triangular base, is 30. Alright, problem number 15. What is the value of P. P means perimeter of the following solid figure. So you have to find perimeter is just adding up the sides. We're going to add up the sides of the base of this shape. And we already talked about what the base was. The base was, or the bases are, the two triangles. So we're going to add up the sides of this base, which are 5, 12, and 13. Okay, I wrote the formula for that. It's just, perimeter is just side plus side plus side. 5 plus 12 plus 13 is 30. So the perimeter is 30. Okay, same shape. Now they're wanting to know the surface area of the shape. And since, remember this, the surface area is, here's the formula. Alright, so I write that there. The last two problems made this problem quite a bit easier because it helped us by finding capital B, which was, it was 30, and the perimeter was also 30. The last two problems, area and perimeter, both of them were 30. Okay, that will not always happen. They will not always be the same. That rarely happens. Okay, and then here's the tricky part, the height. What height are they talking about? Because the height in this problem was just the height of the base, which was just 5. But this height right here by the perimeter is asking for the height of the whole cylinder. This is the height of the cylinder right here. Okay? 15. So don't get confused there. When you're finding the base, they're wanting, which was a triangle, this H was this height, the height of the base. But when you're looking for the area of the whole pyramid, the height of the whole, not pyramid, sorry, prism, the height of the whole prism is 15. 2 times 30 is 60. 30 times 15 is 450. Add those up and you get 510 square inches because it's area. Alright, number 17, what is the volume of the solid figure? Going back to the formula sheet, the volume is just base times height. The base, remember it was up here, was 30, so we just have to write 30. Height, again, this is the height of the whole prism, 15. And 30 times 15 is 450. And since this is volume, it'll be cubic centimeters. This is where you use the 3 instead of the 2. Cubic versus squared. Volume uses cubic, area uses squared. 450 cubic centimeters for the volume. Alright, problem number 18. A cylinder has a height of 1.5 centimeters and the following base. 4 millimeters is the radius. What is the volume of the cylinder in cubic millimeters? And they italicized this because this is tricky. They gave you centimeters for the height and they gave you millimeters for the radius. You can't have different units. They have to be the same. So we're going to have to convert 1.5 centimeters into millimeters, and to do that all you have to do is multiply it by 10 and it becomes 15 millimeters. Okay? Changing centimeters to millimeters, you just multiply by 10. 15 millimeters. Alright, so don't use the 1.5, use 15. Here's the formula. It was also on the formula sheet right here. Pi, we know, is 3.14. Radius is 4, and they want it squared. Remember, that means 4 times 4, not 4 times 2. And then they want height, which is 15. So we're going to change this to 16, not 8. Everybody wants, they say, oh, square, 4 times 2. No, it's 4 times 4, 16. And then we have to multiply these three numbers. and we get 753.6 cubic millimeters. All right, problem number 19, same cylinder, same trick. They want it in millimeters, but they gave you centimeters. But because of the last problem, we know it's not 1.5, it's 15 millimeters, okay? We have to plug in these numbers into this formula, which will look like this: 2 pi radius squared, 2 pi radius height. Okay, and we have to do these separately, and then we can add at the very end. Let's do the squared part first. 4 times 4 is 16. Everything else just drops down. Then we can multiply. We'll multiply this section first, and then we'll multiply this section. Okay, so we multiply these 3 numbers and we get this. We multiply these 4 numbers and we get this. Now we have to add these 2 together. And that is 477.28. So the surface area is 477.28. And this is area, so it's centimeters squared, not cubed, squared. Problem number 20. If all the dimensions of the cylinder are tripled, what will be the new volume? Okay. This is different than problem number 4, where they said what will be the new surface area. So we took the number, they changed the dimensions 5, and we squared it, and we got 25. This is volume. It's a little different. What you do for volume is you take, tripled means 3, so all the dimensions were multiplied by 3. And since we're looking for volume, we don't put a 2, we use a 3. Cubed. Remember all the times I said, if it's area, you square it. If it's volume, you cube it with 3. Anyway, so we take 3, and we bring it to the power of 3, which means 3 times 3 times 3, which is not the same as 3 times 3, okay? You have to multiply 3 by itself 3 times. We do that. 3 times 3 is 9. 9 times 3 is 27. So the new volume is going to be multiplied by 27. So looking back, the old volume was 753.6. Okay. So we're going to take that number, 753.6, old, and we're going to multiply it by the factor 27, because we cubed 3, and that'll be our new volume. And that becomes 20,347.2 cubic millimeters. I'm just going to put it right here with 3. So I made the mistake on problem 19 and put centimeters. I see that now. So I'm going to cross that off and put millimeters squared. Alright, that's the end of study guide 710.